I copy this factor, 5x minus 4 to the 6th. I copy this factor. And now I'm simplifying inside here. So this is 0 and 3, 210x plus 35. 35 times 6, always correct my numbers because I may miss something. So 35 times 6x, I got this. 35 times 1, I got this. Negative 18 times 5, I got 0 and 90x. Am I correct? Plus 2 and 3, 72. Please correct my numbers if they are not correct. Okay, so then final step, I have to add or subtract these two and add these two, and that's it. 5x minus 4 to the 6th. 210 minus 90, I think I have 120x. Correct my numbers always. And plus 107, I think, over 6x plus 1 to the 4th. And this is done. A lot of work with simplifying these. A lot. Okay, back to Pearson. I would like us to, I lost my page. Okay.
I have a question.
Yes, yes, please, please. Any question? Yes.
How many questions would they be?
You're saying about on the test?
Yeah.
Not more than 12 questions, 13 at the most, with an extra credit on top of that.
Okay.
Okay. I would like us to look at a word problem now. And then look at 1.8 and then come back for more problems.
2063?
Yes. Okay. So compound interest, we are given the formula. If 1,000 is invested at an interest rate of R, we used this formula before. Compounded quarterly, 4, n equals 4. For 5 years, right here, 4 times 5, 20. It will grow to this. We have the formula. Find the rate of change, dA over dR, and give its units. So R is the interest rate, and A is measured in dollars, compounded quarterly, which means n equals 4. Okay? So this is the y variable, this is the x variable. So we're going to copy A equals, so this is 63 on page 172, 1,000 and 1 plus R over 4 raised to 20. So first of all, they are asking us to find the rate of change. So let me stop sharing. Okay. So we can be asked to find A prime. They wanted to be a little bit more sophisticated, and they said, okay, find dA over dR, which means A is a function of R as we see it here, but it's the same thing with finding A prime. It's a different notation. So in order to find A prime or dA over dR, see, this is a number in front. This is a function raised to a power. So our formula is this. A function raised to a power. What function? This function raised to power 20. A function raised to power 20. So 20 times the function to 19 times the inner function prime. But when we bring down 20, we already have to multiply it by 1,000. 2 0 and 3 more zeros. And then we have 1 plus R over 4 raised to power 19. Now I have to multiply by this function prime. And I would like you always, when you look at this function, also see this. We talked about this and decomposing with your own eyes or in your own mind. So when I see R over 4, I see 1 over 4, or I see R times 1 over 4, or 1 over 4 times r. They're all the same thing with r over 4. I omitted the 1. I was discussing this. So let me not confuse you, and let me just remove the 1 from here. So r over 4 is the same thing with r times 1 over 4, or is the same thing with 1/4 times r. This is what I want when I differentiate this. Because 1 prime is what? How much is 1 prime?
0.
Excellent. This is more difficult if you want to differentiate, but if you see it like this, it's not going to be difficult. So instead of differentiating this, differentiate this. And that becomes easy now. What is it?
1 over 2.
Exactly. Exactly. Of course, I don't like numbers all over the place. They're factors. So 2,000 divided by 4 is 5,000. 20,000 divided by 4 is 5,000. Times, I don't like to write it here, sorry. I don't have enough room. So it's 5,000 times 1 plus r over 4 to the 19th. Exactly. Now, remember this, these are two measurement units. R is percent. A is in dollars. Since A prime has two measurement units, this is the measurement unit for A prime. So A prime always has two measurement units, and they have one over the other. The top one comes from the y variable. The bottom one has to come from the independent variable, or x or r in this case. There is a part B here. Part B, explain what dA over dr represents. So we gave the units, we determined dA over dr, and now we want to explain what it means. So it means this. A prime is the rate of change. How fast, and it's positive, how fast is the amount changing per percent, per measurement unit, for how fast is A changing with respect to R? How fast, or the rate of change, how fast is A changing with respect to, lazy people write with WRT, with respect to, I'm kidding, but it's easier to write, with respect to R. How fast is A, the amount changing with respect to R, which is the annual interest rate. Very good pick. I would like to discuss 1.8, and we'll come back. I think you're going to find 1.8, the last section of this chapter, the easiest, I think. We'll see. Has a very impressive title, Higher Order Derivatives. Impressive, but nothing to it. We lost Allison, she's coming back. Okay, what does higher order derivatives means? Okay, this is the first, this is the second, this is the third, and so on and so forth. So if I have, let's say, f of x 3x to the 5th, and I want to find its derivative, can anyone give us the answer?
X to the 4.
Excellent. Now if I want to find the second derivative, I have to multiply 15 by 4. I get 60, x to the 3rd. If I want to find the third derivative, I'll multiply 180x squared. And I can continue a few more times. Why is this important? Here's an example. If, let's say, s of t is the distance function, s prime of t is the rate of change of distance with respect to time, which is the velocity function, or speed. So that's the first derivative of the distance. So we can call it v of t. And the second derivative, s double prime t, will be the acceleration. The acceleration function, which we denote by a of t. So not just the first derivative is important, but even the second derivative, and in some cases the third derivative. Not in this class, but we can be asked to determine them. Now, what is the other notation? So f prime of x is the same with dy over dx. But how will the second derivative look like? What will the third derivative look like? Well, a little bit weird. The second derivative of y with respect to x twice, d2y over dx2, d3y over dx3 will be the third derivative. Just for you to know that there is another notation. d2y over dx2 means the second derivative. d3y over dx3 means the third derivative, and so on and so forth. I want to share my screen and look at few examples. And I forgot to look at the page. I have it right here. The page is 179. 179. d2y over dx2, so we can determine, like we just did, or the second derivative. It's the same thing, it's a different notation, but I would like to jump to word problems, and we'll come back to these ones. They're all the same, just more work. So given, that's my page 8, 35, and that was on 179, s of t, t to the third plus t, and they want us to find v of t, they want us to find a of t, and the velocity and acceleration when t equals 4 seconds. Perfect. Okay. So this is a distance function. So we have the distance function. We differentiate it to get the velocity. We differentiate this again to get the acceleration. So can anyone help with the velocity? Can anyone give us the velocity function?
3e squared
Plus?
1.
Excellent. That's the velocity. I can immediately plug in 4 for it, in it. So 3 times 4 squared plus 1. I have to square first. I get 16. I multiply by 3. I get 48. I add 1. I get 49. What is the measurement unit? And you can say you didn't tell us what was S measured in. S is in feet. T is in seconds. So S, feet, T, seconds. What is the measurement unit for the velocity, which is a derivative?
Per second.
Thank you very much. Excellent. V, the rate of change of S with respect to time. Awesome. Now, can anyone give us the acceleration? Which is the derivative? 60. Very good. Awesome. And we can determine A of 4. 6 times 4, 24. Careful. The measurement unit for acceleration cannot be the same as the measurement unit for velocity, because the acceleration is the rate of change of this with respect to this. And the rate of change of this, which is measured in that, and with respect to this, which is measured in seconds. So it cannot be the same. So what will be the measurement unit for the acceleration?
Is it feet per second squared?
Excellent. This is at the top, feet per second at the top, over this, which is second. That's how we get feet per second squared, because you flip 1 over second. That's why we get second squared here. Indeed. This is it. This is the end of the chapter. Let's look at a word problem, or we just did a word problem. So let's look at anything else you want from here. So let's practice. I would like to look at 13, unless you want to choose something else. 13 and 15, something like that, or you choose.
Actually, can we do that? 13 and 15?
Yes, I'm just copying them right now. And 15. Please do not miss Wednesday. Wednesday we're going to review. We're not going to do any new material. The entire session on Wednesday we will review for the test. Please do not miss. I know I'm recording everything, but if you can come, please do. Okay, so for this, we're asked to find the second derivative for both. So the first derivative, 4 x to the third, I want you to remember the derivative of this is very important. So this is 3 times 1 over x. Now we know how to read it. And we know that 1 over x prime is negative 1 over x squared. So minus 3 over x squared. So please remember 1 over x prime is negative 1 over x squared. Now the second derivative is more difficult, because I have to change this first. So f prime now has to be written like this, so we can differentiate it a second time. Why we're differentiating a second time? Because the problem was asking us to find the second derivative for these functions. This is easy, 12x squared. Here I have to multiply. I get positive 6 x to negative 3. And you can leave it alone. I'm fine with that as is. Now the other one, 15, so I'm going to copy it here. Well, this is almost over, I guess. So f of x equals x to 1/3. This is not a friendly function, because when I find f prime, I bring down 1/3 and subtract 1 from 1/3, and I get negative 2/3. There are a lot of functions like this one in this book, a lot. So now the second derivative, I have to multiply these two powers, and I get negative 2 over 9. 1 times 2, 3 times 3. And I have to subtract from negative 2/3, I subtract 1. So it's negative 5/3. And you can leave it alone. It's okay. So before I forget,